In this video, we're going to talk about gamma. Gamma is actually what derivatives and options are all about. Conceptually, gamma describes how much the delta of our derivative changes when the asset moves. Mathematically, the gamma is the second derivative of the option value with respect to the underlying asset. We're not going to worry about exactly what the form of what the function is for this gamma, but we just want to talk about what it is. Again, if we remember our calculus, the second derivative is the curvature of a graph, or represents the curvature of a graph. If the second derivative is positive, we call that graph concave up or convex, and if it is negative, we call that concave or concave down. So let's look at a couple of positions. So we'll put 1,000 call options. We'll buy them for fair value. So we have just bought some options. If we look at our value graph, we see a function which opens upwards. That's a convex function or a concave up function. The gamma is positive. If we clear that and look at short 1,000 options and update our chart, we'll see that we've got a concave function or concave down function. Our gamma is negative. Again, if we look at our summary, we'll see that the gamma is negative for this position. In fact, we've quoted gamma in two different ways, one which we've called gamma notional, the other which we've called gamma unit. In this particular instance, they are the same. The gamma unit is the slightly more intuitive way of quoting a gamma. So the gamma unit is quoted as the number of units in the underlying, or number of shares, that the delta changes for a 1% move in the underlying asset. Now it turns out because our spot is 100, the gamma notional and the gamma unit are the same. There are situations when it's more convenient to use gamma notional and situations when it's more convenient or easier to think about the gamma unit. So let's look at some gammas. Remember, we are short some options here. Now, the gamma on a call and the gamma on the put are the same. Let's look at the gamma, for example. So here's a gamma. This is a short option position. We can see the gamma is always negative. If I clear my position, book a trade, and then we'll buy 1,000 options. So now we're long. We update our chart. We can see a positive gamma. And so this is roughly how gamma works. Now gamma is the derivative of delta. So let's look at the delta for a second, and we can think about the gamma. So here is the delta of an option. We can see when the stock is really low. Now we're a call option, so that represents when the option is way in the money. We can see the delta is basically 0 and doesn't change. Well, that means the gamma is 0. Up here, where the stock is very, very high, we see that the option is way in the money. The strike on this option is 100. The option is way in the money. And again, the delta doesn't change very much when the stock moves by a little bit. Again, the gamma is 0. The gamma is most interesting in the middle, in between very low stock prices and very high stock prices, when we're close to the strike. And it's there where the gamma has the most meaning, the most interesting points for the gamma. You'll see the gamma is fairly large at that point. And what that means is that because we have a large gamma, that means the delta changes relatively rapidly. So when we have a large gamma, it means that as the stock moves around, our delta is going to change. Which means, again, if we're trying to maintain a hedged portfolio or a delta hedged portfolio, it means we're going to have to rebalance our hedges relatively frequently.